Well, welcome to revolutions. And usually people are not welcome to revolutions, and revolutions are not something to be welcome to or at. But these revolutions are in science and technology paradigms. We all know that science and technology are the force that changes our lives. We study science and we do technology, and they come back and change the way we live. And many paradigms, not in 10 years, 20 years, just 5 years, things have changed dramatically in the classroom, in the recreation, you name it. Each aspect of our lives have been changed and touched by science and technology. And it's my privilege today to introduce to you Gabe Przygoda. And you want to read his reports, you want to see him discussing a topic, very civil and very broad-minded, and it's a joy to have him speak to us today. And just talking about Raspberry, I was my brother talked to me one time by phone and said, "I'm calling you from my BlackBerry." So as somebody who is not very good in technology, I told him, "I have a pound of strawberry." Would it be good to call you? But anyway, it seems raspberry and blueberry and strawberry are some things different now, changing paradigms. So without much ado, please join me in welcoming our speaker.
Well, thank you, everyone. Like I said, my name is Gabe Przygoda. I am a graduate assistant here on campus. I'm studying computer technology in the School of Technology over in Clem Hall here on campus, and I also work as a trainer in the CATS student training department here on campus. So today we'll be talking about the Raspberry Pi and how it's redefining the meaning of personal computing. So to begin, this is a photo of what the Raspberry Pi looks like. Now, I'd read about this for a long time before I actually purchased one, and everyone said, well, it's credit card size. It's so cool because it's so small, but you really don't have a concept for how small this device is until you actually hold one in your hand comparatively. And you'll see that this is a small device, and we will get into some of the functions of it, talk about what it is, how it can be used, and how you can get started with your very own Raspberry Pi. So I'm just going to set this aside for now. And our first topic is what the Raspberry Pi is. So the Raspberry Pi is a credit card sized computer. It was created by Eben Upton, who's this man here, who's holding one up, and his colleagues over at Cambridge University in the UK. And he and his crew have formed the Raspberry Pi Foundation, and they sponsor the creation and generation and upkeep of the Raspberry Pi and its software. So the Raspberry Pi is unique because it's a Linux-based computer. So this entire unit functions as a computer by itself, obviously when plugged in with power. And the unique thing about this device is, with our iPods and our smartphones becoming so expensive and so tiny, they've been able to maintain the price at a mere $35 plus shipping and handling. So depending on where you source it from, the price ends up being closer to around $45, but that just kind of depends where you get it, or if you buy it off eBay or Amazon or something like that. Now, the specifications are what makes the Raspberry Pi so unique. Now, you'll see the memory is only half a gig, 512 megabytes of RAM, not a whole lot compared to our processors today, where things like 8 gigabytes and 16 gigabytes are becoming standard. But with these drawbacks also come some benefits as well. So the processor is an ARM11 chip that only clocks in at about 700 megahertz to begin with. Now the top two specs are computing power that you could think of as what maybe a late 90s desktop would have in comparison. So not necessarily up to date by today's standards, but the really unique thing is that the processor is really easy to overclock. So you can get about 1 gigahertz of processing power by simply overvolting it and overclocking it. And if you've done stuff like me where I've got heat sinks on it that kind of manage your cooling a bit better, you can increase those speeds as well. But what's really unique about it is the graphics Video Core 4 GPU chip that's also integrated into the central processing unit. Now, this chip on this board allows you to decode Blu-ray quality video at the full 40 megabits per second in a 1080 resolution, which is extremely unique for a device that is this small. You would expect not a lot of processing power, but really the power comes from the GPU. And because of that, it's had many implications in personal projects as well as home entertainment. The other unique thing is that it comes equipped to perform on a simple 5 volts charge via micro USB, which you can see on the side here. And we'll go over all these specs in a little bit more detail down the line. But just imagine being able to embed an entire computer in something where previously you would only have access to maybe a microcontroller that had a lot less computing power. So this is the basic layout of the board itself as provided by the Raspberry Pi Foundation. Now we're going to be talking about the Model B today. They make 2 models in the Foundation, the Model A and the Model B. We'll be talking about Model B Revision 2, which is the most recent version. And the main distinguishing factor between the Model A and the Model B is that Model B has 512 megabits of RAM as opposed to Model A, which has half of that, and it doesn't have the dual USB ports or the Ethernet port available. Model A was intended more for basic educational purposes, for classroom settings, to where the Model B is designed more for tinkerers and developers. So one of the main uses that people have found that this device can be extremely handy in is the ability to automate your home, automate the life around you by using the general purpose in and out pins on the board here. And I can just pass this around for you guys to see if you like. So you can observe the pins and the in and out points. And so essentially what this man did, Jake Byrne down here, had a simple hack where he bought a basic home automation kit that was infrared controllers that essentially had outlets which plugged into these receivers. And so then you could activate power to the switch by triggering this remote here. And it was essentially an on-off switch that implemented each of the outlets in the room. And what he did was essentially hack apart the remote, rewire the inputs and outputs to the pins on the Raspberry Pi, and now he can control his home, his media center, his lamps, his audio system via the internet for the small price of a few Legos and $35 plus shipping and handling. So this is unique because it's much more powerful than existing microcontrollers that were on the market. So typically an Arduino would be implemented for something like this, but you'd also have to try to deal with the smaller amount of RAM, the lack of processing, and you'd be kind of confined to a regular script. And so getting it to the internet might not be as easy. Another option that you can do is you can transform this Raspberry Pi and harness the power of its GPU and its HD decoding and essentially make any TV or monitor a smart TV. So there are a variety of software add-ons that are available for the Raspberry Pi, mainly focusing around the Xbox Media Center, which has recently been open sourced and is developed for a variety of platforms. So the one that I typically use is the RaspBMC image, which allows you to offload some of the computing power onto a USB, and we'll kind of go over this setup later on, so that way you guys can kind of see the way that the network functions and stuff. Another option is OpenELEC, which is essentially a different port, a different flavor, if you will, of XBMC. And another kind of different sort of video serving software is Rasplex, which essentially allows you to turn a Raspberry Pi server into a Plex server. So Plex is a video server that is designed for home media stations, and it actually has the ability to like kind of transcode and like send out different video signals to different devices. And it's interesting to me because you can get this all to function on a super small credit card sized device. The other options that you could use this Raspberry Pi for would be to host your own website, for example. Other options would include a personal cloud. And so you can see some of these examples down here by simply hooking up Raspberry Pi, configuring scripts and opening holes in your router to where the internet can get in and people can log onto your website, and essentially connecting the Raspberry Pi with those scripts to some sort of storage where you host your website. So in this case, it's just a simple hardware dock where he actually maintains a blog on his projects. This is homecomputerlab.com. Or Ian Nichols' example, where he just kind of made his own stand out of existing parts and recycled an old hard drive. These are all examples of how you can simply set up your own home server to either add a website, or you could implement a personal cloud, or set up a blog for tinkering and showing your implementations throughout the future. Now, what makes this unique is that the Raspberry Pi itself only draws about 3 watts of power, which is extremely efficient compared to existing laptops and desktops. So if you think about it, if you go home and you look in your desktop computer, you just spin it around, you'll see that the back power supply is probably rated at least 250 watts, probably more around 400 watts. So just imagine a server setting where something is designed to be constantly running all the time. Even if you had access to a cheaper desktop, your power draw and your consumption of energy would probably be much less efficient than something that the Raspberry Pi could provide. Another option, and what I am currently using the Raspberry Pi for, is as a network attached storage device. So I've paired the Raspberry Pi with the Windows Samba software, which essentially allows you to create a server that's attached to a local Windows network that can be picked up by most devices that are pre-configured with either like Windows Vista or Windows 7 or something like that. And I've added an external hard drive. In this case, this is a representation of my model, which is the Seagate Backup Plus. It's 4 terabytes. And I just use an Ethernet connection to hang it essentially off of my local network. Now, this is what I've done recently, and I've essentially put it inside a box enclosure that allows me to have the entire thing encased with a power hub in addition to Ethernet, and I've got a fan rigged up in here as well. So for this box, what I have is I'm working on creating a better fan control, but the Ethernet will go into the router, and then up here I have 2 buttons where I've triggered some scripts to run. So the first one is a reset switch, which allows me to turn the Raspberry Pi on when power is drawn to it. And the other one is an off button, essentially. So it's plugged into the GPIO header 5 right down here. And what that does is it's constantly scanning these pins for an input. That's the way the script runs. And then whenever it senses that a button has been pressed up here, it sends a shutdown command. So because it's a bare bones computer, you have the ability to run it as is, or you can build up your own sort of casing around it as you choose. I'm going to put this on the table now, and then we will kind of talk about how this all works together later on. But for now, we're going to move on to one of my favorite options that are available with the Raspberry Pi, which is software and game emulation. So one of the first questions that was posed whenever the Raspberry Pi first kind of came out on the market around the beginning of 2012 was, well, can it run Minecraft? Minecraft, of course, is the classic blocky sort of builder game. And the answer is yes. And there is a Minecraft Pi Edition. You can also not only run Minecraft, but you can also host a Minecraft server on one of these Pis and have about 3 to 4 players if you configure it right without a lot of lag, which is pretty cool for such a small device. Additionally, you can use it for portable computing. So this is an example of a 3D printed case that uses a Raspberry Pi in the base here. There is a wireless keyboard that's attached up the top, and this also uses a monitor that's kind of all been printed together with a portable battery inside here as well. If you want more information about that, you can check out the Parts People blog. He has this list of components and things that they use to make this. I think the parts ranged from about $250 to $300 because they had access to a 3D printer. But it was more of a can we build it? And the answer was yes, we can, as opposed to practically using a laptop or something like that. Another option that was really cool is that these Raspberry Pis are small enough to fit inside existing Game Boy cases. So if you have one that's dead or just so old that it doesn't run anymore, you can actually gut the innards out of a Game Boy, replace the screen with a smaller little like 3.5 LCD screen, and then you can route either power to it or have it kind of export your data out of USB on the side. Several people have hacks for these, and you can also use them as regular computers in addition to gaming emulators. Another useful feature of the Raspberry Pi, since it does feature kind of outdated peripherals as far as the CPU goes, is you can use it as an MS-DOS box or an Apple emulation. So you can scrounge those old codes from the early 90s that don't really exist anymore, that might not be supported fully on your brand new desktop, and relive the glory days of the Commodore 64, the NES systems, Super Nintendo, and there's been guys who've even gotten Nintendo 64 and some PS1 emulators to run as well on these Raspberry Pis. Here's an example that combines most of the things I love in one video. They use a Raspberry Pi to decode live sound from an NES game and then synchronize it with actual instruments. So this is using a Yamaha player piano. And essentially what this does, in real time, decodes the sound and plays it. So in this video, the sound is being decoded into MIDI files that are getting sent to both the piano and then data files that are getting sent to the servos that are controlling the drum triggers, essentially. And they're keeping pace with the sound in real time, and they can also do even more complex sounds as well. So for example, classically, the Legend of Zelda theme song has been a little bit difficult, but the Raspberry Pi can keep up. But one of the main reasons that the Raspberry Pi was invented was to further education of computer programming and just to make more people aware of the ways that computers work, and to hope that the endeavor will provide a more computer literate society as well. So this is why I kind of gravitated towards the Raspberry Pi myself, and why I believe it's such an influential paradigm that we can talk about in the realm of technology, because as it stands, the Raspberry Pi is not necessarily new technology. Linux, the operating system, has been around for quite some time. The essential components are nothing that's extremely cutting edge, but it's the pairing of the low price tag and the overall design that is something that can shift the learning of our world, essentially, into a more computer literate society. So this is Eben Upton and a photo of Google Giving, which donated 15,000 Raspberry Pis to a group of students in the UK to be parsed out as they choose. And so with this low price tag, for example, of the Raspberry Pi Model A, which doesn't have Ethernet and only has 256 megabytes of RAM, for a price tag of $25, we're now seeing students around the world who can access basic computing start to learn more hands-on with programming. For example, each image is packaged with 2 programs that are extremely useful for teaching kids how computers work. So the first one is Idle, which is a basic editor of Python script, which is an object-oriented code that allows students to manipulate the way that their Raspberry Pi reacts with other sensors, scripts codes, and allows them to essentially start automating the Raspberry Pi and programming it to do things that previously we would kind of just view as an operating style as opposed to an actual programming style of computing. The next one is Scratch, which is actually a program that's designed for animation as well as for creating simple games. So this is giving, like, for example, 12-year-olds access to being able to make short movies and short cartoons, as well as some kind of cool video games. And this is what really triggered the paradigm shift for me, because back when I was in school, we were kind of taught, this is a computer. You need to learn to type on it because this is how you're going to do your homework. It's important to know how to use the internet, and that was kind of the extent of it. In high school, it was more, okay, we're going to type in a lot of papers, and occasionally we're going to pirate stuff off LimeWire. And since then, through the computer technology, I've learned a little bit more about computers on my own. But back in the day, the main emphasis on computers was essentially being able to type efficiently and being able to know where your home row was, and you got the little cardboard cover, and that was the extent of our knowledge with computers. It was just basically how to input information into them. To where now we could potentially structure curriculums to teach, computer languages, how to code. Imagine if kids could grow up learning how to speak English in classes, but then also how to write code alongside that as they're growing through their primary years of schooling. These Raspberry Pis are designed to be kind of kid-proof in a way. I mean, they're set up to where they're not necessarily as prone to static electricity. The price tag is kind of disposable in a sense, so that if something does go wrong, let's say a soda gets spilled on them, the replacement cost is very minimal compared to buying a brand new desktop, which could range from $500 to $1,500. And letting a kid mess around with it. The way this is set up, the images can be written to SD cards, and then if you mess up that image or something gets horribly screwed up, you can just shut it down, take the SD card out, and write a different image on it, or fix the file that's broken. So this has huge implications for being able to code in the classroom, and that's the primary driving force behind the Raspberry Pi Foundation. To kind of highlight some of these concepts, I've got this short video that I'd like to showcase, which is taken from the Raspberry Pi Week that they did in conjunction with the High Tech, High Media Arts. And the video kind of speaks for itself, but we'll talk about it a little bit after it's done.
$35 is well spent. I think it's really interesting that in this day and age, everyone uses computers so dependently, and they have computers in their pockets and they carry them around with them everywhere. But not very many people know how they actually work. And if you give them a computer without a nice, fancy user interface, then they really won't know what to do. And I think that's sort of amazing that we depend on them so much, yet so many people have no idea how they work. So I wouldn't like to be a part of that demographic. I'd like to know how they work and how to make them work better.
I think it would be cool to learn how they actually work and not just click buttons and not know what's happening. Actually have a deeper understanding of why you're using it and how you're using it.
I wanted to make a computer, and I also wanted to learn more coding.
Mine's going to be a home theater system that I'm going to connect to my TV. This PS1 game emulator that I'm messing with.
I'm doing an Arch Linux, in which case I need to download most of my GUI command line prompt right now. But once I have it functional, that is the automation, which is like making lights turn on and off with voice commands, or putting it inside an old notebook as a sort of a mobile toy.
Just a lot of reasons. I just want to learn how to make a computer.
So this kind of showcases some of the implications of the Raspberry Pi and some of the applications that people around the world are able to use and harness the power of the Raspberry Pi to add technology, essentially, where previously technology was not available. But primarily the quote that I like to focus on is the little girl in the middle who mentioned the fact that we are so constantly tied to computers, but not many people actually know how they work. And this is the boat that I found myself in when I first heard about the Raspberry Pi. Now, I graduated from undergrad with a degree that essentially was electronic media production. And I used computers almost every day. But aside from the software that I was familiar with, I'd had no idea how they actually worked at a programming level. So I kind of jumped in the boat here, essentially where these junior high school kids are starting up, and decided that I was going to take this trip to figure out, one, how this Raspberry Pi thing works, what Linux is, and how I can use it. And I also wanted to learn how to solder up stuff and you know, make my own circuits and make stuff that does something, but essentially comes from parts from like Radio Shack or something like that. So I'd like to pass this knowledge on to those of you out there who might like to start using the Raspberry Pi for themselves. And keep in mind, this is all from my own personal knowledge from troubleshooting here and there. So it might not be exactly the best information, but it's what I found from researching on forums and troubleshooting myself. But essentially, there's a couple things that you need to get started. So to begin, you'll need a Raspberry Pi. Now, I would recommend the Model B, as we've passed around. And then you're also going to need a 4 gigabyte SD card as kind of the minimum volume. So the Linux images that you'll probably be writing to this are very, very low in terms of the space that they will take up. Compared to the operating systems of like Apple or Windows, where you're looking at gigabytes upon gigabytes of information for your operating system alone. These are much smaller images. You're also going to need a 5-volt cell phone charger. So probably one that you have lying around will do, but you need to make sure that it's at least 5 volts. What happens sometimes is if you get one that's like 4.9 or is not consistently putting out 5-volt charge, it can actually corrupt your SD card, and because it's not getting enough power to the board, so you might have to reset your card every once in a while. The other thing you're going to need is an Ethernet connection, so some way of downloading updates and getting new information onto the Raspberry Pi. You can simply connect your Raspberry Pi to your router via an Ethernet connection, and you're also going to need a USB keyboard and mouse. And I would also recommend using a powered USB hub. Now for these, I've found that the Aquagate ArcView hub, it's got 7 ports on it, and it also provides 5 volts of power, is one of the best on the market because it's super cheap. It's only about $18, and if you have a Prime account, it will ship in 2 days from Amazon. But the placement of the hubs is what I find very, very helpful because it's got 2 on this side with also your USB in. So this is what you'll run to the Raspberry Pi itself. It's got 5 volts in DC, this is solid, and it's also got 2 ports on the top and 3 on the side. So with this configuration, it fits very well on a desk, or in the example of my NAS device here, I've got it set up to where it's sandwiched in between the board and the edge of the box, so I can hook my peripherals up and still run data and power to the board itself. And there are a number of devices that will work to power the Pi. I would recommend checking out elinux.org. They've got a list of verified peripherals that will work. But this is just what I found that is, it works for my budget and for the amount of devices I want to power. Now, another issue might be the amperage that's available with your circuit. So for example, if you're going to plug in a lot of devices to your Raspberry Pi, you're going to need a power supply that has more amps associated with it. This is a 2 amp 5-volt system that plugs in to the hub. So that's allowed me to power the Raspberry Pi, my USB keyboard, an external hard drive, as well as a USB key, all simultaneously. Oh, and additionally a Wi-Fi USB adapter. So that's about all I could think to plug in at one time. So that test held up for mine. I would assume that it would hold up for yours as well. So after you get all these components together, the next thing that you're going to need to do is you're going to need to decide what kind of operating system you want to load up. So obviously you're probably going to stick with something that's Linux-based because not many other things are supported because of the chipset that's available on there. But I would recommend starting with the Raspbian Wheezy image, which is the endorsed image that you can download off of raspberrypi.org. And it's a scaled down version of Debian Linux, which has been out for a little bit, and it's fairly stable. There's a lot of resources and a lot of people who have coded with it. But it's open source, so it's free to download, as most Linux plugins and software are. So essentially, once you download this file, what you're going to need to do is unpack it and extract it to this SD card so that the Raspberry Pi can then unpack it and configure it to where it's a usable image. So to do this, you can use a disk imager, for example, for Windows. Windows 32 disk imager is available. There's also extensive tutorials if you just simply Google this process or look on YouTube. There are numerous people who have very, very advanced tutorials for Mac, Linux, as well as pretty much every flavor of Windows available. And you can also find more instructions on the raspberrypi.org downloads page to kind of point you in directions of some of the other sorts of operating systems that are available. Now after that, you're going to have to connect the Pi and wire everything up. So over here we've got the image loaded on the SD card. We have the power coming out of the mini USB jack on the side. This is an HDMI display port. You could also choose to run it out of RCA video, but for most purposes and most things you probably have in your house already, the HDMI would probably be better suited because you can push a higher resolution. You're also going to need to add an Ethernet port or add a connection to your Ethernet port and get some sort of internet connection. And then I would also recommend adding your mouse and your keyboard, or additionally you could run that to a USB hub that has more devices plugged in. But that's just kind of what it looks like all wired up. And then after this, you're going to have to just kind of boot up the image. It's going to start unpacking. It's going to start unloading itself, and it's going to download updates as well. And this is going to just kind of set in the operating system onto your card and allow you to, after this process is done, log in with the default. Your username will be Pi, and your password will be Raspberry. So you can follow these tutorials as you choose online, or you can just kind of go your own way if you want and just kind of learn it for yourself. But there are numerous tutorials. Because this is such an open source endeavor, there's a lot of people out there who have already done this, who have already screwed it up, and who have already figured out ways to make it go as smoothly as possible. So there's even software available that automatically loads up your SD cards. You can even buy preloaded SD cards, so you don't have to worry about actually downloading stuff. You just kind of put it in and watch it go. The next thing that you probably want to do is you want to connect some peripherals to actually get your Raspberry Pi to do stuff. So by itself, the Raspberry Pi with the stock image will just kind of function like a regular computer. You can do things like word processing and web browsing and stuff like that, but that kind of sucks the fun out of the Raspberry Pi because you probably want to make it do something because of its capabilities and its form factor. So one of the things you could do is you could connect a USB keyboard. That's in my case it's a wireless keyboard actually, and essentially the way this works is on the side here you unplug the little receiver and plug that into a USB port, and then you can configure this and use the mouse pad that's attached as well as the keyboard to enter your code, especially when you're in the command line terminal and needing to access different files and stuff like that. I found this works really well because it's nice and lightweight, and it holds a charge that is insanely long. I haven't really had to recharge this because the system, whenever it's on, it only sucks power whenever you press a key. so it holds power really, really well. And I've been super pleased with the purchase. Also, it's really cheap for what it is. And being a graduate student on a non-grant budget, I like cheap things that work well. So moving on, we have a variety of shields that have been developed, which are essentially breakout boards that allow you to do more things with your Raspberry Pi. This one in particular is a prototyping shield that's developed by Adafruit, and it allows you to manipulate and build circuits off of the pins that are on the Raspberry Pi, and you can add chips. Notice they've got a button and an LED, so you can kind of configure the inputs and outputs as you wish and start designing your own programs, your own circuits and stuff like that, and build upon that as well. I'd also once again recommend purchasing a hub that's powered, so that way you can run a power source to your Raspberry Pi as well as get a data line out and have it all in one container that has one power jack as opposed to having 2 or 3 plugs that have to power everything up. You might also want to connect it to a traditional monitor, so you could get an adapter cable such as an HDMI to a VGA or HDMI to a DVI connection, depending on what you have lying around. And you might consider getting a case as well. So this one is just a basic case that's sold by the Mod My Pi store. And there's a variety of cases available. People have been putting them in all sorts of things. For example, mine up here on the table is a project enclosure box from Radio Shack. But you can also get more creative and, for example, put yours in a set of Legos and build your Pi into a housing as you need. And you could also, if you had a 3D printer available, you could do what Sean Reagan did and 3D print a case. So this is actually an example of a solar-powered Raspberry Pi. On this side, he's got the Pi housed in the bottom. On this side, he has rechargeable AA batteries, and on the top, he's got a solar panel. So I don't think it necessarily works for continuous play, but for a couple hours, it'll hold the charge and rejuvenate itself in direct sunlight. Over here, though, we have Professor Simon Cox and his son James, who were part of a study at the University of Southampton. And what the University of Southampton typically tries to do with their computer departments, they try to find new ways of computing, specifically trying to maximize their output out of small devices. So what they did was they were actually one of the first largest consumers of Raspberry Pis, and they have got a 64 Pi cluster supercomputer rigged up. And the easiest way they were able to figure out to get the form factor to where it would fit without having to take up a bunch of racks and things was to use Legos and build towers. And that's where James comes in, because he and his dad were able to put together these racks that easily organize all 64 Raspberry Pis, all their connectors, and provide space and enough headroom for cooling as well. Now, this Raspberry Pi cluster is not necessarily as effective as you might think, because it's a limitation with the gigabit internet, and also it's kind of an underpowered system. But however, if you need multiple operating systems as your supercomputing, this would be a way to go. And they were able to build essentially this entire rig for around $4,000. So for the amount of gigaflops that they get out of it, it's pretty good as far as the price to power ratio goes. And also it's just a good example of how you can start experimenting with supercomputing and parallel processing without having to drop a ton of money and invest in like server blades and all this extra space and cooling and all the things associated with that. I highly recommend checking out the article and the video that's associated with this story. Also, it's pretty cool because they have made the cluster software available to the public to download. So if you wanted to make your own, you can essentially mimic and copy and paste their program onto your own Pis and have your own supercomputer Pi cluster. Now, as we start to wrap up, I'd like to kind of start closing with this quote from the Raspberry Pi Foundation, which kind of exemplifies their philosophy with what the Raspberry Pi has to offer. And they say that we don't claim to have all the answers. We don't think that the Raspberry Pi is a fix-all to the world's computing issues. We do believe that we can be a catalyst. We want to see cheap, accessible, programmable computers everywhere, and we actively encourage other companies to clone what we're doing. So this philosophy is something that engineers, basement hackers, young kids can get behind. And the price tag is something that allows them to further their own knowledge without having to worry about scrounging together enough money or worry about the cost of failure. And because of this system being so successful, there have been a number of competitors who have come out with similar systems. And I think this is great because it gives a lot of people more options for their own computing. And I'd like to highlight two of them that I found extremely interesting. Now, one is a system that was released only earlier this month. It's called the BeagleBone Black. And essentially the specs are very, very similar to the Raspberry Pi, except that one, it has rounded corners, so it can easily fit inside an Altoids tin, which is what it was designed for. The Raspberry Pi narrowly makes the form factor of the Altoids tin. It's that corners stick out a little bit, so it doesn't necessarily work that well. The RAM on this is the same amount as the Raspberry Pi, but it clocks at a faster speed. Also, the processor is natively set to 1 gigahertz, as opposed to the Raspberry Pi's 700 megahertz processor. Additionally, it's got 2 gigabytes of internal storage space, so you don't even necessarily need an SD card to put an image on it. And the price tag is very, very, very close to the Raspberry Pi with an MSRP of $45. So technically only $10 more, and you get a device that is comparable and might be better for certain instances, especially if you're using this for something more along the lines of like robotics and automation. Now, this other system on the side here is Adaptiva's Parallella board. Now, this board was Kickstarter funded, and essentially what Adaptiva's plan for this board is they believe that we're fastly approaching a bottleneck with our computing power. We're not seeing the same gains by doubling or tripling our RAM as we were back in the day when we were jumping from Pentium to dual core and stuff like that. And so they think that the way of the future is going to be parallel computing. So what they've done is they've come up with this board that is capable of running Ubuntu Linux, which is a more graphics heavy version of Linux. It also has a 1 gigahertz processor, but it also has gigabit internet, which means that the supercomputing applications are much more friendly in this instance, and it's actually designed to form these small clusters. So a cluster like this is available for about $500, and you can start messing around with supercomputing using their own proprietary Epiphany processor, which has, I believe, 16 cores to it, and they're planning on releasing a version in the next couple of years that has 64 cores. I'm not entirely sure how they work their magic, but they have a team of designers who strongly believe that making boards affordable and available is the way that we're going to kind of break through this bottleneck, because the more people you have working on problems, the more likely you are to find a solution sooner. So at this point, I will take any questions that are that you guys have about the Raspberry Pi. But before we head out, I would like to do a quick demonstration of the way that I use my Raspberry Pis in my home setup to just give you an idea. So first off, any questions? All right. Second of all, I'm just going to do a quick simulation of the way that I use it, because I've tossed a lot of concepts at you guys, and I don't know how much is fully sunk in. So imagine that this is my home router. So what I've done is I've taken this device right here, which functions as the network attached storage. So with a simple Ethernet cable, I will plug this into the router. So what this is able to do now is this is able to attach to the local network I've set up. So then what I can do from here is I can take Raspberry Pi number 2 and I can install the media player. And I'll route this up to where it pulls from this drive. And I've got the image loaded on this card. And so what this will do is this will connect with this drive using a USB jack, and I'll also add this small Wi-Fi dongle, which will allow this device to compute with to communicate with the overall network and pull files from here. So what I've done for essentially under $200 is set up a home media streaming system by pairing the Raspberry Pi with existing peripherals and adding a little bit of storage here and there and a couple codes. So this is only one small application of the Raspberry Pi, but there have been many others, and I would recommend that if you are interested in using the Raspberry Pi for one of your own projects, that you just simply Google Raspberry Pi and then add whatever project it is after it, because there's been a lot of people who have been developing these boards. As of about last week, they reported they had 1.75 million of these boards sold, and they had their 1 millionth produced in the UK. So they're making strides for being only available for about a year and a half now. So thank you for being such an attentive audience. And